record this? Yes. For the sake of the students who are absent, I'm going to record. So the first branch of the tree map, the ones, the three on the left, I'm going to write those down. I'm going to write adjacent angles, complementary angles, supplementary angles. And going to write the definitions down. Let me make it one screen here. There we go. So we're just doing the first three. I'm zooming in on the first three branches. So relationships. This is relationships among angles, which means you need two or more. So you have adjacent angles, complementary angles, supplementary angles. And underneath is a small definition, and I'm going to give you a small picture that you and I are going to draw of each kind. Now, the neater you write, the better, because you'll be allowed to use this on your assignments, quizzes, and tests, which are all open note. So, adjacent angles. So I'm just going to start drawing the pictures here. The adjacent angles here, angles right next to each other. This word adjacent, we use it in common English. Like if I say the hallway is adjacent to this room, that means it's right next to this room. Miss Doris's class is adjacent to my class. Mr. Rios' class is adjacent to my class, because we're right next to each other. That's all adjacent means. So I'm going to draw two angles right next to each other. Draw it with me. Let's call this angle A, B, C, and CBD. Notice how ABC and CBD are right next to each other, two angles right next to each other. So I'll put angle ABC and CBD. They're adjacent. They're right next to each other. They share a common side. Right? They share this side right here, this ray BC. Just like me and Mr. Rios share that wall, me and Ms. Goda share that wall here. Two angles that share a side are adjacent. That's another way of seeing it. Pretty straightforward. Cool. Complementary angles. Angles that add up to 90 degrees. Each angle is a complement of the other. So I'm going to draw two angles that add up to 90 degrees. Instead of just two angles willy-nilly that are just next to each other, now two angles that add up to 90. Draw it with me. Here we go. The video you watched last week, remember this is a 90-degree symbol, this box? That shows that it's 90 degrees. But look what I'm going to do. I'm going to draw another angle here. I'll call this angle P. I'll call the vertex Q. And then angle RQS. So notice angle PQR and angle RQS. If you add those two angles up, they're adjacent. If you add them up, they're going to equal 90 degrees. So we call them complementary angles. Okay. So I'm going to write. I'm going to write a little equation here. Angle PQR plus angle RQS is 90 degrees. Right over here. Okay. Notice the two angles that are adjacent, they add up to be 90. They add up to be a right angle. So far, so good. How about supplementary angles now? Let's draw some supplementary angles. Right, they would add up to be a straight angle. Very nice. Watch. Very good. So let me draw a straight angle. That's 180 degrees. But let me draw two angles now that add up to be 180. They're right next to each other. So let's call this ABC this time. And this one D. So look at how angle ABC and angle CBD, they're next to each other and they add up to be 180, a straight angle. So I'm going to put up here angle ABD plus angle CBD equals 180 degrees instead of 90. Remember last week you watched videos on straight angles, right angles, which should have been reviewed for most of you. Okay, so far so good. Vertical angles in linear pair. So vertical angles are two angles formed by two intersecting lines. They are always congruent. I'm going to get into what this word congruent means shortly. For now, just write the word congruent. Let me get into that right now, shortly. And then two adjacent, look at linear pair are two adjacent angles. You already know what adjacent means. Sure, go ahead. You already know what adjacent means. That was our first angle relationship. Thinking that. Okay. So here, notice the two intersecting lines here. I'm going to put arrows to indicate that they're lines. Now let me show you the angles that are vertical angles that are formed. So this would be one pair of vertical angles. This would be another. So this would be one pair. They're always going to be the same. So congruent just means the same measure. So for now, let's go to write same measure for the word congruent. I'll get into the formal definition right now. So let's go ahead and name these angles here. Let's name this X. Let's name the vertex Y and Z. And this one will be A, Y, and this would be B. So angle XYZ and angle AYB will be the same measure when two lines intersect. And I put this little arc here with a little hash mark. That's usually the symbolism on a picture that tells you, look at these two angles are the same measure, the same degrees if you were to measure them. Angle XYZ, that's this angle, and AYB, they have the same measure. That's all the congruent means. They're the same measure. But that doesn't stop there. The other two angles that are going to be congruent, that are called vertical angles, are this angle, XYA, and ZYB. Look at these two angles are going to be congruent also. They'll be the same measure. This always occurs when two lines intersect. Again, are you with me, right? So look what I'm going to write. Angle XYZ. We know the name of angles. Again, I'm referring to the blue one here. Angle XYZ is congruent. This is the symbol for congruent. It's got an equal with a little D laid over it. And all this means is the same degrees. Angle XYZ is the same degrees or congruent. Same degrees as which one? AYB. Angle AYB, huh? You guys with me? Because it has to get these two, they're always opposite. Vertical angles are always opposite each other. So congruent just means same degrees, same measure. and it's an equal sign with a little tilde over it. Now look at the other two angles. The other two angles were angle XYA is congruent to ZYB, angle ZYB. Those are the ones I highlighted in red, right, PHILO Math? All right, so far so good? Yes, go ahead. Yeah. All right, last one. Linear pair are two adjacent angles that are supplementary. That means they add up to be 180. Their non-common sides form a line. So let's call this angle, I'm going to put some arrows here. Let's fix this picture up here. So let's call this P, Q, R, and then S for now. I'm going to add your picture and edit your picture to look like mine. We're going to write some statements regarding these linear pairs here. So notice angle PQR, that's this angle, and angle RQS, that's this angle. They're adjacent because they're right next to each other, and they're supplementary. That means they add up to be 180. Because notice if you go from here all the way and rotate all the way over here, you're going to have half a circle, which is 180 degrees. And look at their right, which is a straight angle. And look at their non-common sides right here. I'm highlighted in blue. Their non-common sides form a line. So this would be a linear pair. A pair is always two things, like a pair of shoes, you have two. Right? A pair of earrings is two. A pair of angles that add up to be 180 that are right next to each other are a linear pair. And the word linear means line. Look at their non-common sides form a line. So look at the statement I'm going to write. Angle PQR plus angle RQS equals 180 degrees. I'll write that on yours. For example 1, I'm going to throw a picture of two intersecting lines here. Let's say this angle is 2x degrees, and this angle is 100 degrees. Let's solve for x here. You got two intersecting lines, and angles that are opposite each other from the intersecting lines. Right? Let's solve for x. Well, the first way I do this is I got this situation. I'm going to compare this situation with my 5-branch tree map. What kind of angles am I dealing with, in other words? Am I dealing with complementary, supplementary, adjacent, vertical, or linear pair? They're vertical lines, or vertical angles rather, right? So this angle, there's two intersecting lines. They're opposite each other. I know they're vertical. That means they're congruent, which means they have the same measure. So I can write, look at the equation I'm going to write. I'm going to write 2x equals 100. They equal each other. At this point, if we have a dirt cheap, easy one-step equation, let's just get x by itself. We practiced this on warm-up, I believe, right? Let's divide by 2. So x is 50. So we're able to solve for x because we identified our angle relationship. There was a relationship going on between the two angles. Let's do one more example and we'll close it out. Go ahead. So example 2, watch this one. I'm going to draw a straight line. Let's go ahead and let's say this angle is 75 degrees. Sure. And let's say this angle is x plus 30 degrees. All right, so we have a situation. The first thing you want to do is identify what kind of relationship is there between the two angles. Ms. Wynn, what do you think?
I think it's linear angle because it has two angles.
Right. So linear pair, huh?
Yeah.
So linear pair. Anybody disagree or agree? Linear pair. They're not. Look at these two angles. The non-common sides form a line. Hence the word linear. Non-common sides form a line. And what's special about linear pairs? Yes, Ms. Wood.
Is that they're not really congruent at all.
Right, they're not congruent. There's something else, though, huh? What do we write down there on that for the trait?
They're
Supplementary.
Supplementary.
Good. Someone besides Ms. Wynn, what does supplementary mean? Buckley.
They added
180. So I know that this angle plus this angle is going to equal 180. So I'm going to set up my equation based on the relationship that we identified. That's why you have that tree map. You're going to constantly refer to it until you start memorizing it. Right, guys? Let's do it. Here we go. 75, that's this angle, plus this angle here, x plus 30, equals 180. So far, so good. So we got 75 plus 30. We can get these like terms together here. That'll be, what, 105? Yeah. So the x plus 105, I'm getting the like terms together there on the left side, equals 180. So far, so good. Let's isolate x. We'll subtract 105 from both sides. So x equaling, what does that become? 180 minus 105.
is
75, huh? Done. So we're able to solve for x because of our angle relationships. Question.